All right, so we're going to talk about pitch. And pitch, in its simplest form, is best defined on what it can do. Pitches can either be high or low. Here's a low pitch. Here's a high pitch. So, pitch is actually what they call a relative concept. A relative concept. That means that we can only understand it in relationship to something else. So for example, the first pitch I used, here is a low pitch. That can become a high pitch if my reference pitch was, here is a low pitch. Here's a high pitch. So we only understand it in relationship to something else. That's a relative concept. There are a lot of relative concepts in music. It's important to know. For example, volume is a relative concept. Is this loud? Well, it depends on what I'm comparing it to. Is this loud? Is this loud? So you get the point, all right? So another good example is rhythm. Here's a tempo. Is that a slow tempo or a fast tempo? It only, it matters whether or not, if it is, you can only tell if it's slow or fast depending on the tempo I'm comparing it to. So here's the original tempo. Here's my second tempo. So that first tempo was slower than the second. A last point of comparison, I'm about 6 feet tall, a little over 6 foot. And in comparison to my wife, she's 5'2", I am tall. But in comparison to my friends, many of whom are over 6 feet, I am short. All right. Now to understand pitch, we have to talk about frequency. We have to talk about frequency. Frequency is the rate of how quickly something vibrates. Okay, so how quickly something vibrates. Things that make music vibrate. So these strings are vibrating. And it's that vibration that causes the air to vibrate, reaches our ear, and we hear music. All right. We measure vibration in hertz. Hertz is how many times it will repeat or vibrate within a second. So it's pretty quick. So you can actually see the A string vibrate. Okay, but it's a bit deceptive because our eye cannot see how quickly it is vibrating. You can see it's vibrating. So in fact, when I hit this string, in a second, it is going back and forth 440 times. It's very, very quick. All right. Things with a higher frequency have a higher pitch and they vibrate more quickly. So, whereas this vibrates more slowly, okay, it has a lower pitch. Size affects frequency too. All right, so we're looking at the violin. You'll notice we talked about the G string being thicker. Okay, so it's a thicker, it's a bigger size, so it vibrates more slowly. And the thinner strings vibrate more quickly. All right. There's another factor that is important to know, and that's density. Density, okay? Density has a large effect on the speed at which it can vibrate. So what you're actually doing as you tighten a string is you're making that string more dense. You're packing the molecules more tightly together. Denser things vibrate more quickly too. All right. Okay, so I thought it'd be good to look at the keyboard here for a second. If you can see it, all right. Great. So low frequencies. Again, it's relative. Oh, there we go. All right. That's a lower frequency compared to this. It's a wicked awesome sound. So as we get higher up to we get this direction on the piano keyboard, the frequencies get a lot higher, and then as we get this direction, it goes lower. Okay. Last thing I wanted to say. Yeah, so just take a second to look at that I gave you here. Okay. We have here pitch is represented by a circle. What's important for pitch information is just where the circle is placed. In this case, it's on a line. You can also have in a space. Pitch information is only ever written on a line or in a space. Where people tend to get confused is where we start to add rhythmic information. You'll notice that this note, an E, the circle, is always in the same spot. Thus, the pitch does not change. What changes is the rhythm. So here we've colored this one in, but the circle's in the same spot. We've added a stem. And essentially, the more stuff you add to a note, the faster it becomes. And that's it.